Hello everyone, I am Shweta and I am practicing in JSS College of Arts, Commerce and Science, Uti Road, Mysore. So my topic is about robustness and ruggedness. So let's know about it. So before selecting any analytical method, the method may be an application of technique to a specific analyte to a specific matrix. So while choosing a method, there are some consideration given to some criteria. So they may be accuracy, precision, sensitivity, selectivity, ruggedness, robustness, cost and even time. So there should be a method of validation for the analysis. So let's know about robustness, as it is the least important but still important for the method of validation. Robustness refers to a product or system's ability to maintain its performance and functionality despite variations, uncertainties or disturbances such as changes in input or operating conditions. It just focuses on maintaining performance, internal or external variations. It focuses on methods, internal stability and free from chemical interferences. So robustness testing involves deliberately varying parameters assess a method's resilience. A robust is an analytical method is one that consistently delivers reliable results even when the minor changes are made to the method's parameter. It's also the feasibility to reproduce the analytical method in different laboratories. The term robustness for expressing the stability of the method against small variations of the intrinsic method parameter. Let's understand with a better example. So as robustness being a method of validation, so the tested result should not change even in different cities, different laboratories, while through different reagents or even through different analysts. While considering the brand, even by changing brand, the result should not change much matter. So by considering a 4 analyst and the concentration would be of 5, 10, 15, 20, 25 and so on, by increasing the concentration, and certain method is given to the analyst and the results are taken by taking a mean and taking relative standard deviation and comparing with it. Comparing those, and the error or the correction should not exceed 2%, which should be less than 2%. So by this manner we can consider robustness being a method of validation in certain factors. As we can see the analyst performing a certain method where the robustness being a method of validation. So our next topic is about ruggedness, where in method of validation ruggedness is least important but still important in some categories. So ruggedness refers to a system or product's ability to withstand and operate effectively in harsh and challenging environments such as extreme temperatures, vibrations or physical stress, humidity, and it focuses on withstanding external stresses. So it is a method that is insensitive to changes in experimental conditions and should be free from environmental conditions. So ruggedness focuses on its transferability and consistency across different environment. So it assesses the reproducibility of results under varied external factors like different analysts, labs or instruments. So it should be used as a parameter evaluating the consistency of the results when the external factors such as analyst, laboratory, instrument, reagents and even days are varied. So it's much similar to robustness. So the term ruggedness for expressing the stability of the method against extraneous influencing factors. The word ruggedness means strongly built or which remains unchanged. So according to United States of Pharmacopoeia, it defines ruggedness as the degree of reproducibility of test results obtained by the analysis of the same samples under a variety of normal test conditions such as different laboratories, different analysts, instruments, reagents, temperatures, and even days. So ruggedness is all about future perspective in another terms. So in case of HPLC, when the samples and the mobile phase are costly, ruggedness may play an important role to make it cost ineffective. As I said before, ruggedness may be a future perspective. So in HPLC, if the samples or the mobile phase are too costly, the ruggedness plays an important role for the cost ineffective method. For example, if we consider a trained analyst versus fresher, the chances of using the costly sample and chances of getting the reproducible results and chances of using less sample or the mobile phase is much better for a trained analyst rather than a fresher. For a particular method, if the criteria of a method validations are satisfied, then it could be a cost ineffective method, as ruggedness in HPLC could be rarely achieved by mobile phases, as it may be a chances of getting mixed with the sample or even getting very less quantity. So if the ruggedness satisfies, it could be a very less cost method. This schematic outlines the sample preparation and analysis workflow used for pesticide residue quantification. To assess ruggedness, critical steps involving time, temperature, and speed were systematically varied. The method showed consistent performance under these variations, confirming its robustness and reliability for routine analysis. Thank you.